A sample of chlorine gas has a pressure of 1.32 atmospheres. If 450.0 milliliters of the gas, this chlorine gas, is held at a temperature of 30.0 degrees Celsius, how many moles of gas do you have? Well, to solve this problem, we are going to be using the ideal gas law. And the reason I know that is because of all of the gas laws, the ideal gas law is the only one that includes pressure, volume, temperature, and number of moles. So our ideal gas law looks like this. PV equals nRT, where P is pressure, and we'll use units of atmospheres. Volume for V, and units of liters. N is number of moles in the unit of moles. R is the gas constant. R stands for the gas constant, which is 0.0821 liters times atmospheres per mole times Kelvin. And then T stands for temperature. And this is in units of Kelvin. Okay, so now that we know what everything stands for in our formula, we need to get all of our given values to match what we need. So we need our pressure in atmospheres, which it is. So we're good there. So our pressure, I'm just going to make a list of what we have, is 1.32 atmospheres. Our volume is 450 milliliters. But like we said here, we need our volume to be in liters. So we need to divide by 1,000, which means to move the decimal 3 places to the left. So it's 0.450. And for significant figures' sake, make sure you keep this 0 after the decimal. So it's 0.4500 liters. Then N is our number of moles. That's what we're looking for. So we don't know that. We do know R is 0.0821. And I'm going to write the units in here. Okay, and then our temperature, T, we're given 30 degrees Celsius, but we need our temperature to be in Kelvin. So to get it to Kelvin, we're going to add 273.15, which 273.15 gives us 303.15 Kelvin. Okay, so now we have everything in the right units, so we can go ahead and substitute these values into our formula and solve for N. But I'm going to start by rearranging this formula so that I'm solving for N to begin with, which means I'm dividing both sides by RT. So N equals PV over RT, which means pressure is 1.32, our volume is 0.4500, R is our constant, 0.0821, and our temperature is 303.15 Kelvin. So now let's do 1.32 times 0.4500, and that gives us, in our numerator, 0.594 with 3 significant figures like we need, divided by 0.0821 times 303.15 gives us 24, and I need 3 significant figures again, so 24.9. So now I'm going to divide 0.594 divided by 24.9, and 3 significant figures in our answer, so 0.0239. That's how many moles of chlorine we have, and chlorine is Cl2.